Hello everyone, we're going to take some notes on functional groups today. All this information is being pulled from table R on your reference table, so you may want to have that out as well to follow along. These notes are going to look a little different than our normal notes just because I'm doing this on my home computer, not my Chromebook, but it follows right along with the functional group table in your notes. So as I'm going over these things, please copy them down. I'm also going to post a link to this slideshow on Classroom with the Edpuzzle assignment, so you could always go back to the slideshow and fill things in if you miss anything or if I'm going too fast. So let's get right into it. Alcohols. All of the functional groups I'm going to go over will have this table where I'm going to have the general formula that I'm pulling from table R, the naming rules that I have typed up for you, and then an example structure that I've also pulled from table R. So the only thing that's not on table R are these naming rules. But these naming rules, you can kind of use context clues to figure out using the name from the example structure that they give you in the reference table. However, again, these naming rules are not given on the reference table, so you do need to kind of remember them or be able to use the example structure to get to that correct name. So the first one is going to be an alcohol, and the general formula for this is an OH group found somewhere in our compound. It can be found anywhere in the compound, so to name these, we do need to number the carbon that it's on, again, following our rule that we want the lowest number possible on that carbon, whether we need to number from left to right or right to left. What we do is take the alkane ending, ane, drop the E, and add an OL to make this an alcohol. So for example, over here, we have 1, 2, 3 carbons, so that's where we get prop. So we wrote propane, we dropped the E and add an OL because of the OH group found. Then we need to number that OH group where it's found. So we can go 1, 2, 3, so be on the third carbon, or we can go right to left and do 1, 2, 3, so be on the first carbon. So we choose the lower numbering there. So this is 1-propanol. Next one are organic acids. These have the OH group, but now they also have a double bond to oxygen. These, for naming, no numbering needs to be used because the functional group's always on the end, whether it's at the beginning or very end of the compound. It's never found in the middle. To name these, we just take that alkane ending ANE, drop the E, and add oic acid to the end. So we use our prefixes from table P for all of these, count the number of carbons, and then adjust the ending here. So in our example, we have 1, 2, 3 carbons, so this would be propane without the functional group, but attach this functional group on the organic acid, this becomes propanoic acid. Again, no numbering because it's on the end there. Next, we have aldehydes, which look very similar to organic acids, but instead of the OH group, we have an H. So we have a C double bonded to an oxygen and then an H. Here, again, no numbering is needed because this functional group's either always at the beginning or end of our compound. To name these, we take the ending ANE, we drop the E, and add that AL there. So for example, here we have 1, 2, 3 carbons. This is prop, so we have propane, and we take that E off and add the AL. So this is propanol here. Next, we have ketones. This looks similar to the ones we just went over, but now it's just a double bond to oxygen on a carbon. So it can be found anywhere in the compound. So we do need to number our carbon where the double bond is found. To name these, we need to drop the E on our alkane naming and add 1 or O-N-E. So for example, over here we have 1, 2, 3, 4, 5 carbons. So we get pentane, and then this becomes pentanone. And then we number our carbon, again, following the lowest number. So 1, 2, it could be on the 2, or 1, 2, 3, 4 on the fourth carbon. We're going to pick the lower number, so we get 2-pentanone. Okay, next we have a ketone. Oh, sorry, no, we just went over that. Just wanted to make sure my thing was recording. Here we have ethers. So this is a oxygen in the middle of our compound. This we actually don't need to number because it has a kind of a funky naming system. This is definitely probably the hardest one of all of our functional groups here. So what we do instead is name the branches coming off of our oxygen on both sides. These branches are going to end in YL, and we're going to use the prefixes from table P just as we have for the rest of the functional groups. So here we have an example. we find the oxygen and we look at the branches coming off of it. So on the left here, we have 1 carbon, so that's where we get methyl. And on the right here, we have 2 carbons, that's where we get our ethyl, and then you just attach the name ether to it. We do these from left to right. That's just the rule, so we don't need to worry about putting it in alphabetical order. So again, we have 1 carbon over here, that's methyl, 2 carbons over here on the other side of our oxygen, that's ethyl, and then ether. Esters, we have a double bond to oxygen and then a single bond to oxygen, and these can be found anywhere in the compound as well. However, just like ethers, for esters, we do not number these. We name something like the parent chain, and then we name the branches coming off of our single bond to oxygen. So we name the parent chain as the one with the carbons leading up to the double bond to oxygen, so this chain over here. And then the branch is going to be the branch coming off of the single bonded oxygen. So esters are also pretty difficult to name, kind of remembering that order. So here we have the double bond to oxygen. So we're going to look at the carbons leading up to it. So we have 1, 2, 3 carbons. So that's where we get prop from. And this again is our parent chain because it's the carbons leading up to the double bond. And the ending, I forgot to write this in the naming rules, but the ending ends in O8. So we go from propane to propanoate. And then we look for the single bonded oxygen and we look at the branch coming off of that, and that becomes the beginning part of our name. So we have 1 carbon coming off, so that's methyl. So this is methyl propanoate. So we name, again, the carbons leading up to the double bonded oxygen is our parent naming, and then the branch coming off is what we start with. Next we have halides. These are just halogens found somewhere in our compound. We do need to number the carbon that has the halogen on it. And then the rules for naming these, that name of the halogen goes in front and we change the ending to an O. All of these names are on table R. We have fluorine that goes to fluoro, chlorine, chloro, bromine, bromo, iodine, what is that? I forget what iodine is, but it's on there. So, we do need to number these, so we name it as normal. So we have 1, 2, 3 carbons, so that's propane. We had the chloro in front because in this specific example we have chlorine, and this is actually on the 2nd carbon. You do maybe want to draw this out because if we look at it, it looks like it could be on the 1st carbon, but it's not. All the carbons here are attached, and that chlorine is actually on that 2nd carbon there. We have amines here next, and these have nitrogens in them that are single bonded. These can be found anywhere in a compound, so they do need to be numbered with the carbon that's bonded to the nitrogen. We take the ending ane and we actually drop the E and add the functional group name, amine, right into the name. So here we have 1, 2, 3 carbons, so we get propane, and this drops the E, propane, amine, and then we number that carbon, so we can do 1, 2, 3, or we can go reverse 1, 2, 3, which will give us a 1 on that carbon with the nitrogen. Similar to amines, we have amides, and we're also, I know in your notes you have amino acids, you can cross those out. They're not on our reference table, so we're not going to go over them. Amides are similar to our amines, and these, though, for our functional group, have a double bond to oxygen and then a single bond to nitrogen. These, no numbers needed because they're always going to be found on the beginning or end of our carbon chains. And this, for the name, we take the ane, drop the E, and add, again, just like amine, we add the name amide right into it. So here we have 1, 2, 3 carbons, so we get propane, drop that E, and add amide to it. No numbering needed here because it's on the end, and it always will be. So that's how to name these. What you're going to do next is click on the quizzes link on Classroom and go through that just to get familiar with looking at compounds and being able to just identify the type of functional group in them. So go through that. When you're done, you're not naming them yet. You're just saying like you would see this and you'd recognize it had a double bond to oxygen and a single bond to nitrogen. So this would be an amide group. So you're not actually naming yet. When you're done with that, then you're going to go over to Classroom and go to the functional group activity. This is building off of that slideshow that we worked on last week. Instead of you working on your own slideshow that you did with your group, I'm actually going to give you the answer key just to make it simple. I've already filled in the type of functional groups there are in red. And then what I did is made up a chart that you're going to fill out. And I have a couple examples here for you to work off of, and you're going to fill in the rest. So what you'll do is have this Cami open and then also the answer key open, and you're going to go right along. You're going to draw out all the compounds, get practice with that, and then name them accordingly. So, for example, I drew this first one for you in the alcohols. So I drew it, and then I used my naming notes to name it. So it says 1, 2, 3 carbons. So this is propane, goes to propanol, and that OH group is on the first carbon there. So it's 1-propanol. I have an ether group for you, so I will go to the next slide. I drew this one on the left. You'll have to do the other two. So here we have, off of our oxygen, we have 2 methyl groups, and actually this should be dimethyl ether, just like we did with parent chains the other day. If we have 2 of the same chains, we can attach the names together. So we shouldn't be writing methyl-methyl. It should be dimethyl ether. Then we go on to the next slide. On our slideshow, we have ketones. I drew this one for you, so you'll have to do this other one on your own. Here we have 1, 2, 3 carbons. So we get propane. This goes to propanone, and we number that carbon with a double bonded oxygen on it. Next, we have aldehydes here. So we go to our aldehyde slides. I did this one for you. You'll have to do the other one on your own. I drew it. We have 1 carbon, so this is methane. And again, no numbering needed. So we just change that E to Al. So this is methanol. Then we go to organic acids. Again, I drew this one for you on the left here. It has 1, 2, 3 carbons in it. So this is propane. No numbering because that's on the end there and always will be. So we just change the E to oic acid. So this is propanoic acid. Then we go to esters here. Esters and our ethers, again, are the harder names, but you can do it. We go to esters. I drew this one for you on the left. So we have, leading up to our carbon with the double bond to oxygen, we have 2 carbons, and that becomes our base name in the red here. So this is ethanoate. And then we name our branch on the side, and this is 1 carbon, so this is methyl ethanoate. So it's, again, the parent name is the carbons leading up to the double bonded oxygen, and then the branch is the carbon coming off of our single bonded oxygen. Then we have our amide group here. So we go to our next slide. I drew this one for you on the left. It has, it has 2 carbons in it. So we have ethane, and then we just take that E off and add amide to it. And then finally, we have our amine group here. I drew this one on the left for you. It has 1 carbon on it, so we have methane. We take the E off, and it becomes methane amine. So you're going to go through and copy all of those down and then fill in the rest using the answer key slideshow I have provided for you. And then you can get that turned into me as soon as you get that done. If there are any questions, we can go over this on Wednesday, but I would like you to try your best on your own with this before then, because we are going to have a quiz on Friday.